Hi, so this is the video for our second review sheet of the two questions you might see on your midterm. So this is again law of sines, law of cosines, area triangle. So the first one has Kathy wants to determine the height of a flagpole shown in the diagram below. She uses a survey instrument to measure the angle elevation to the top of the flagpole, determines that it's going to be 34.9 degrees. She walks 8 meters closer and determines the new measured angle elevation to be 52.8 degrees. At each measurement, the survey instrument is 1.7 meters above the ground. Determine the state to nearest tenth of a meter the height of the flagpole. All right, so we're going to name, I guess, the different parts here. I'm going to call, in this case, this point A, this point B, this point C, and this point D. All right, and so one of the things we want to do here, we know that AB is actually equal to 8 meters as well. So AB equals 8 meters because, well, it's the same measurement. All right, because again, we're looking at line segment ABC, it's above the ground by 1.7 meters, but parallel, so the measure of AB is also going to be 8 though. We want to find the measure of angle ADB. And we can find the measure of angle DBA by doing 180 minus 2.8. But because we know, we should know in this case, that angle CBD is an exterior angle of triangle ABD, we can find this by just doing 52.8 minus 34.9. And therefore, this measurement is going to be 17.9 degrees. Okay, so yeah, you could have found angle ABD and subtracted 52.8 from 180, and then found that measurement, add 34.9, subtract that from 180. But we still know in this case, exterior angle of a triangle will make things a little easier for us. And so again, we now have a combination of an angle measure and a measure of the side opposite. So here we go. This is going to be law of sines. And we're going to use the 34.9 to find this measurement here, dB. So we're going to do the sine of 17.9 over 8 meters is equal to the sine of 34.9 over dB. And so we got dB by itself, we're going to get dB is equal to 8 times the sine of 34.9 degrees over the sine of 17.9 degrees. All right, so let's take our calculator. And so we're going to do, in this case, 8 sine, here we go, 8 sine of 34.9, close parenthesis, and divide by the sine of 17.9. Okay? And we're going to get a measurement of 14.892, and so on and so forth. So we'll do 14.892. Okay, so dB is approximately 14.892. Now you might be asking, why are you rounding, so far out? Because near 10th. I mean, I'm going to round off to a little further out because the further out you go, less of an error you're going to make. If I round to nearest 10th now, I'm going to have some errors, later on possibly. Okay, so we have this measurement here. Okay, and now what we're going to do is we're going to focus on this triangle. Now we're going to find the measure DC. I'm going to call this X here. Okay, so to find the measure DC, we can use in this case law of sines again if we want to, because this is 90 degrees. But we also know in this case that the sine of 52.8 is equal to X over dB, which was 14.892. So X is equal to dB, which is this measurement here, times the sine of 52.8 degrees. Okay, just cross multiply, right? And now the great thing is that on my calculator, I already have that measurement always set. So let's go to the calculator. And so we're going to do that measurement. So just hit times, and then it's the sign of, in this case, 52.8. 52.8. Okay, enter, and we get 11.86. Okay, 11.86. So x equals 11.86. All right, great. But that's not the height, because we want the height of the flagpole. And the height of the flagpole is going to include the 1.7, because that's how far the sensor is above the ground. So we add that together, and so we add, so let's go back here, just going to add 1.7, and we're going to get, in this case, 13.56, which is going to be, in this case, round off to approximately to the nearest tenth of nearest centimeter, we're going to get 13.6. Okay. All right, so here we had to use the law of sines and we had to find angle measurement because it was kind of hidden, but this was really going to be an angle side situation, or really angle side angle if you want with angle dBA. I usually try to use the middle part dB because it's a little easier. And you could find AD if you want to, and then use the larger triangle, but it's the same thing though. Okay, so our second question had us at the rhombus ABCD, measuring angle DAB is 121.3 degrees, and the length of each side is 20 centimeters. Find the length of diagonal DB to the nearest tenth of a centimeter, and then find the area of ABCD to the nearest square centimeters. Okay, so here we want to find DB, if you want to call it, we'll call this lowercase a. Here's lowercase a, and so this is law of cosines, and so a squared is equal to, here we're going to label this as lowercase b, and this is lowercase d for triangle ABD. Okay, so a squared equals b squared plus d squared minus 2bd cosine of a. And so that means in this case, and if we want to take the square root of anything, so a is equal to the square root. This whole thing here would be 20 squared plus 20 squared minus 2 times 20 times 20 times the cosine of 121.3 degrees. Okay, now I just took the liberty of taking the square roots right away, and so yeah, this is fine. This is totally good for work-wise. Okay, you want to know, in this case, label in this situation what your sides are and what you're plugging in. Okay, so let's clear the calculator, and so we're going to do in this situation second square root, so we can do everything in one shot. 20 squared plus 20 squared minus 2 times 20 times 20 cosine of 121.3 degrees. Again, you have to make sure you're in degree mode, and we're going to enter this in calculator, and we will get 34.86567495. But we want to find the nearest tenth. So nearest tenth. So we're going to round this up to 34.9 centimeters. So A equals 34.9 centimeters. Okay. Okay, so that's the first part. Hopefully not so bad. Now for the second part here. We want to find, in this case, the area of the whole rhombus ABCD. So normally we would use K, which is the area, is one half in this case, BD sine of A. But that would only cover this much. one of the nice things in this case is that a rhombus, triangle ABD is really exactly half the measurement because the triangle ABD and triangle BCD, so triangle ABD, oops, I should not use this. So I'm going to use a regular pen. So triangle ABD is congruent to triangle CBD. And because of the fact that, in this case, opposite angles of a rhombus are congruent and all sides are congruent, therefore you can have two triangles congruent because of side angle side. And so if they're both congruent to each other, they should have the same exact measure. Therefore, or same exact area. So therefore, we're going to do K is equal to 2 times this, which really is going to be just BD sine of A. Okay, so we're going to multiply this by 2. Okay, because we have 2 triangles here. And so now we'll plug in, and so it's just, we're going to take, in this case, the area of the whole amount is going to be 20 times 20 times the sine of 121.3 degrees. Okay? All right, so let's go to calculator. All right, and so we're going to do, in this case, 20 times 20 times the sine of, oops, not that button, times the sine of 121.3 degrees. And we will get, in this case, 341.7, which will round up to the nearest square centimeter, 342 square centimeters. Okay, looking for nearest square centimeter, so 342. So area of ABCD is equal to 342 centimeters squared. Again, we know how to find the area of triangle, but the whole thing, the whole rhombus in this case, and this works with parallelograms too, because the diagonal of a parallelogram will divide the parallelogram into 2 congruent triangles, and therefore the areas of the 2 triangles must be congruent. Therefore, you have this to find the area of a parallelogram, use the formula, but instead of 1/2 AB sine C, or in this case 1/2 BD sine A, we'll just double that to get BD sine of A. Okay, hopefully it's helpful, and hopefully this will be, you guys go over this, prepare for the midterm. And if you have any questions or comments, please leave them below in the comment section below. If you found this helpful, all right, please leave a like, and of course subscribe to the channel and turn on notifications for any videos that will show up in the future. Okay, thank you so much, and appreciate you guys watching. Take care and be safe.